Here we are going to learn about system and network evolution. The history of optical fiber transmission has been all over about how to transmit data at the highest capacity over the longest possible distance. The aim of all optical network was based on keeping on the data signal entirely in the optical domain form source to destination to eliminate the so-called electronic bottleneck. To realize the benefit and challenges of all optical networking, it is instructive to review the state of transmission and switching in optical layer. So the evolution is the first multimode fiber. Early the information encoded in a light signal could be transmitted over glass fiber waveguide. So waveguide provide a medium that can guide the light signal, enabling it to stay focused for reasonable distance without being scattered. This allows the signal to be received at the other end with sufficient strength so that the information can be decoded. An optical fiber is very thin cylindrical glass waveguide consisting of two parts, inner core material and outer cladding material. The core and cladding are designed so as to keep the light signals guided inside the fiber and allowing the light signal to be transmitted for reasonably long distance before the signal degrades its quality. The early fiber were so called as a multimode fiber. Multimode fiber have core diameter of about 50 to 85 micrometer, and this diameter is large compared to the operating wavelength of the light signal. So initially consider one example like that, the one signal P in lambda. So this is one signal line. So here in the block of the transmitter, so the case of the multimode, so the transmitter is known as a LED, and then provide a multiple regenerator path. So this is using multimode fiber, and the last block is a receiver. So this fiber cable is known as a multimode fiber cable. So in the early system, LEDs are used for multimode fiber transmitter. A system using MLM laser over a single mode fiber is also been there. So the second, single mode fiber. So used single mode fiber means eliminating intermodulation dispersion. Single mode fiber has relatively small core diameter of about 8 to 10 micron, which is small multiple of operating wavelength range of the light signal. Using a single mode fiber effectively eliminated intermodal dispersion and enable a dramatic increase the bit rate and distance possible between regenerators. This system typically had regenerator spacing of about 40 km, and operated at bit rate of few hundred megabits per second. The next step in the evolution in the 1980s were deploying the stream that the 1.55 micrometer wavelength window to take advantage of lower loss in this window relative to the 1.3 micrometer window. If we reduce the spectrum of the transmitted pulse to the something level close to its modulation bandwidth, the penalty due to the chromatic dispersion is significantly reduced. This motivated development of a laser source for the transmission from the light source with narrow spectral width, the distribution feedback laser, so DFB laser. So in the case of single mode fiber, so the signal frequency are that something like that. We use a transmitter, the source as a laser or MLM laser. So I'm consider about only L for the laser. So we can use the distance between the regenerator. So in the above case, consider the two regenerator is there. So in the below case, only one regenerator is required between transmitter and receiver because of use of single mode fiber, and the distance 1.3 micrometer the line. So in the system using laser over a single mode fiber in the 1.3 micrometer band to overcome intermodal dispersion in multimodal fiber. So here the length diameter is 1.3. So the next, optical amplifier and WDM. So next major evolution of optical fiber transmission system is iridium doped fiber amplifier, EDFA. The capable of amplifying signal at many wavelengths simultaneously. This provide another way of increasing the system capacity. So using EDFA and WDM, reduce the cost of transmission and increase the capacity, and also achieving capacity over a 1 Tbps over a single fiber. So using external modulator along with the DFB, distributed feedback laser, and EDFA allowed system to achieve distance of about 600 km at approx 2.5 Gbps between generator over a standard single mode fiber. The next invention was that the chromatic dispersion compensating technique, and it is used for the compensate for the dispersion introduced by the fiber in optical network. The fourth one is transmission linked to networks. The formation of metropolitan area networks meant such as to the higher than 100 Mbps fiber distributed data interface FDDI, and the networks to interconnect mainframe computers such as approx 200 Mbps enterprise serial connection ESCON. The new major concept like FTTH, fiber to the home, and FTTC, fiber to the crowd.